I want to take you, we've got where we are right now with the research that we have on these issues. I want to try and, I'll tell you about a project that I'm just completing for NIJ that I think is one of the important pieces of moving on into the future. And then I want to give you a peek at what I think the future is of bringing experimentation to bear on the field, how to measure what really matters, how to enhance justice, which has been one of the themes of this conference, and improve safety and reduce costs, and do it all at once by trying to understand how the physical and the human limits of human beings doing this job come to bear on what we're asking them to do and the technology we're providing for them. Sometimes good technology, sometimes too much technology, we'll see. My sponsors, I won't thank them all, but I appreciate every one of them. And of course, they're not responsible for anything I say, just me. In case there are any lawyers in the room. All right, so when we try to protect our protectors, which is the theme of this panel, what do? We use training, we change policies, we change the practices in the department. But how do we know what we're supposed to train to? We use expertise. There's a great deal of that out in the field. But I'm a scientist now. I used to be a cop. And as a scientist, I'm a show me the evidence guy. Where's the hard evidence? What does it lead us to? How do we know whether our interventions succeed? How do we improve them? How do we find out what's more cost effective in a time when there isn't enough money to go around and we're laying people off? All of those issues are very important for us. Well, we use science, that's our goal here. But before we can use science, we've got to identify the likely causes of the problems we want to deal with. No giant rocket science involved here. And we've got to develop tools for measuring those problems and the causes of the causes of the causes of those problems. So it's not enough to just measure what's going on. When we look at inside a deadly force encounter where an officer's been killed and we analyze what happened, which has been wonderful research that Tony Pinizzotto and Ed Davis and Shannon Borer, for example, have done, that tells us some things about what happened and what was associated with it. But what was upstream of that and what was upstream of that? That's where we get the answers that can help us really change the way the world works, keep people safe, find the new answers that we haven't thought about because we don't know enough. We've got to develop tools for measuring those problems. That's the key to this problem, this measurement problem. Oftentimes, like Einstein said, we settle for measuring what we can measure rather than what really matters. I'm trying to push that boundary a little bit farther out. Let me give you an example that'll probably piss some people off in this room, okay? And I get to because I spent a long time as a cop and as a police chief before this. Every officer in this country is trained and certified as being qualified to do that job. And those certification standards come from their Police Officer Standards and Training Commission or some such thing in the state they work in. Okay, everybody agrees that these are the right standards. Good people with good experience work at them hard. Deadly force, largest category of training that recruits get in most basic academies. It's an expensive piece of it. The performance outcomes of this training, if you want to concentrate it down into one simple sentence, accurately identify a threat, neutralize it, while minimizing harm to bystanders, to officers, and to the suspects, because sometimes they're not really the suspects, and once you shoot them, you can't take that bullet back, right? Situations are complicated. What we don't know is what the impact of that training on deadly force is on combat performance. I know how many bullets you can put on a target in what condition. I know what you can do in a role-playing situation, in a simulator, but we don't know what happens on the street and how that relates to the training a person has had. Think about this, Does it improve combat training performance or combat performance? Does it reduce the likelihood that force will be necessary? Getting back to Jim Fife's long ago big point, the best officers are the ones who can avoid having to get to the point of having to use deadly force. They can manage people. Do the types of training have an impact, or the most, which ones have the most bang for the buck? The deal is we've been doing this for 100 years. We've been training people, and we still don't know the answer to the most basic question, which is what's the connection between that training and what happens? So we've been doing this measuring what matters. We'll call it MWM on the slides to save some space in deadly encounters. I'm going to use this as an example and then step back into where we're going in the future. Okay, so these are fast-paced, very dynamic social situations, these deadly encounters. They're often ambiguous. Often there's very little time to make a decision and act on it. Well, what we're trying to do in my lab is develop some more precise ways of measuring them. Get to an interval level where you can use, which is researchers speak for a very precise yardstick that I can bring the strongest statistical tools to bear on analyzing what happens and does it mean anything or not. Okay? I want to adapt the other phase that we're doing, and this is the latter part of what I'll say this morning. We're adapting the kinds of simulations, especially the high-fidelity computerized simulations, that police departments around the country and the military all over the world are using as training devices. We're hacking them and using them the way Carrick's approaching this, okay, using those devices as a surrogate for what one would see in the field. This is important because deadly force encounters, for example, are very rare. It's one of the things that makes it a difficult problem to tackle. The idea behind this is that I want the fidelity, the precision, the replicability of laboratory research, which is kind of our holy grail, but I want to bring to it the validity of field research. This is a very realistic set of challenges instead of something highly abstract. Karen's research targeted this same kind of a method using some scientific tools that are traditional but are very abstract and using some more realistic simulations of it. I think that when we do this, on top of being better science, it also gives us a better chance to translate our research into practice. It's easier to stand in front of a police audience, like I do lots of times every year, and say, we did this thing. This is the tool we used, which is the tool you used, only we steal the data, we do this and that to get at it, and here are the results we have. Let's look at the first part of this problem right quick, and I'll give you an idea of how you get to measuring what matters. You got to identify what matters. Well, we got 24 of the top experts in the country together, which is a miracle all by itself. We got a very diverse group, from a young, the best street cop in his department, to some of the folks who'd been doing it for 30 years, to the people who ran, they're anonymous, so I can't say who, but folks who run the major training organizations or the major trainer training organizations, people who run big academies, scientists who've been on this topic for their whole careers. We got them to agree, well, first we got them to agree on this focus prompt, this very brief statement of what are you trying to accomplish in a deadly force encounter. If you look at the rules of engagement for most police departments or for military units, they're usually page after page after page. Here's one bloody sentence, but it's the one that a guy on the street or a gal on the street takes to work with them. We looked at what are the things that affect your performance, that increase the odds that you'll do better in an encounter, because the reality is sometimes you can do everything right and it still goes to crap. We all know that. And then we also looked at what are the elements of the situation in which this happens that make it more difficult to have a good encounter. We looked at things like Dave Klinger's raised with normal accidents theory. You know, what is it? Number of people? I'll give you some examples. Here's some of the ones that this group came up with. You know, performance variables. We had 105 of these. Things like, can you clear a malfunction? Do you maintain a good stance to give you an advantage, give you some balance to work from? Are you using available cover? Are you hitting the suspect when you shoot at him? Difficulty things. Does the suspect have a firearm? Are there things in the way? Is there less distance or more distance? The second part of this, though, is putting values on those increments on the yardstick that you're building. And to do that, we sent surveys out to 289, I think it is, police officers who are active deadly force trainers all across the country, more than 200 different departments, all sizes of departments, all regions of the country. And we get the answers back about how much it's worth to be this distance away, for example, versus that distance versus the next distance. How much is it worth? All right. So how about in other tasks, though? In addition to deadly force, this is where we're going right now with research funded by Office of Naval Research, the Defense Advanced Research Projects Agency, and Department of Transportation. We've got driving, especially distracted driving on top of deadly force. We've got cognitive functioning, risk propensity, implicit bias, and we've just added, since I wrote this thing, we've got the funding to do tactical social interactions. So the more human parts of the interaction, the thing that Karen's test gets at, only we've rolled this from the ground up as an instrument for use in this. When we look at work-related fatigue, which is long-term, as you've heard, my big issue, we look at how it impacts that performance. So the idea is to get those two things tied together, use real police officers in a laboratory. Because I'm running out of time, you know these scenarios. Why is that officer yawning in the middle of a deadly confrontation in front of a National Geographic reporter who was working with us? How did that officer in the corner there go from being a skinny rookie 20 years ago to someone that obese with life-threatening sleep apnea? How did this officer, in the middle of a Sunday morning going up a hill with no traffic, have a lapse of attention? He went straight, the road turned, and he went straight through a swarm of bicyclists coming down the hill. Don't wince, Tom. It was a terrible tragedy. Let me shift to the video now. So we've got about 5,000 square feet of controlled laboratory environment. Everything's controlled temperature, light levels, all of the pieces. We use high-fidelity driving simulators. We use real cops whom we outfit with neurophysiological measures. We have, in the deadly force simulators, we've rolled our own simulations using real actors based on LEOCA data. They even swear in the simulation, if you can believe that. And they're mean. We test deadly force judgment and decision making. We look at arousal. We look at what's going on in the brain. We look at how people are breathing so we can get a measure of what's going on physiologically with them. The soldier who was doing that, we have a cannon that shoots back at you. We've dealt with the acoustics in the range to make it sound like a gunshot is going off when a gunshot goes off, so you can hear people's voices. It's a laboratory environment. Operational driving, quite similar to what Carrick's working on. We're very interested in distracted driving. We have funding from California Police Officer Standards and Peace Officer Standards and Training Commission to look at this aspect of the problem. 80 subjects, all 4 shifts. Bring them in as tired as they get in the work week, as rested as they get in the work week, and then do the same thing again with even more instrumentation. This is an easy test. You got to drive at 55. You got to follow a vehicle, stay within 100 feet of it, don't run into it. And you have to do a cognitive test half the time, where you reach over and you punch the right line and pick the right words. It's a cognitive test that's been used in lots of drowsy driving or distracted driving research around the country for more than 10 years, well validated. seems easy, it's harder than hell to do. And the question is it even harder to do when you're tired, as tired as you get on the job working real police work? The eye gaze, like Carrick was showing you, the red line is where your head is pointed toward. The green lines are what your eyes are looking at on the screen. So you can track how much time people are spending looking down. And this isn't even a real police cockpit, right? Where it looks like it was human factors designed by Rube Goldberg. You've got all sorts of devices stuck all over. You see police officers driving with their knees and typing and looking at the road like this. The other device that I'm really excited about is the functional near-infrared imaging of the brain, where we can measure objectively cognitive workload. We can measure what's going on in the part of our brains that makes us a human being, where we make moral decisions, where we evaluate the consequences of our acts. How hard is a person thinking? How much attention are they having to focus on it? Which parts of the brain are lighting up? Are they the ones you want lighting up right now? So that's what we're after. And with that, I'll open it for questions. And I just want to thank, there we go. Let me just take you for 1 second. Think about this. Since the advent of modern policing, one of the things we've been trying to do, every supervisor, and I've been a police sergeant, make sure they're not sleeping on duty, right? Well, I got a news alert for you. It may be that the thing we want to do is in the middle of the bloody night when nothing else is going on, bring them home, have them nap a little bit, and get them rested up a notch. But we'll ask me in 18 months when we've got this current round of research done, and I'll be able to give you an answer about that. Thank you.